Hi guys, welcome to 6.5. In this section we're doing a lot. We are doing graphs of tangent, cotangent, cosecant, and secant. So let's start with tangent and cotangent. And the first difference here between sine and cosine graphs is the period. So the period for tangent and cotangent graphs is actually pi, not 2 pi. And if there is a b, let me slide this down. If there is a number in front of the x, like the sine and cosine, it's pi over b now to get the period, not 2 pi. Another important thing, the way I graph tangent and cotangent, is to figure out where the starting asymptotes are and our 5 key points. So if you look across the unit circle, there are asymptotes at negative pi over 2 and positive pi over 2. And then tangent of 0 is 0. And then these other key points would be pi over 4 and negative pi over 4. And at negative pi over 4, tangent is negative 1. And at positive pi over 4, tangent is positive 1. So these are kind of the 5 key points that I start from when I do tangent. Okay, so let's actually start there. So let's try a tan graph. So I'm going to start, like I always do with these, and do tangent without any transformations. So what if it was just plain old y equals tan of x? So I'm going to make my table of xy, and I'm going to use these 5 key points here. Negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. Those are going to be my 5 key points. And then the y's, let's see, well, at negative pi over 2, it's undefined because it's an asymptote. At negative pi over 4, tan is negative 1. At 0, tan is 0. At pi over 4, tan is 1. And at pi over 2, it's an asymptote, so again, undefined. Okay, now let's apply our transformations. If there is a 2 in front of the x, remember we always do the opposite. So we're going to divide by 2 in the x. And then in the y, we're just multiplying all the y's by 3. All right, so let's get all the transformation values. If you divide by 2, I'll use a different color. This becomes negative pi over 4. This is now negative pi over 8. 0 divided by 2 is 0, and then positive pi over 8 and positive pi over 4. And then if you multiply all these by 3, this is still undefined asymptote. Negative 3, 0, 3, and undefined asymptote. Okay, now let's sketch our graph. Okay. So we have negative pi over 4 and positive pi over 4 as the asymptotes now. At 0, we're still at 0. And then at negative pi over 8 and positive pi over 8, let's see. At negative pi over 8, we're down at negative 3. And at positive pi over 8, we're up at positive 3. And then if you connect the dots, they will curve toward the asymptotes. And that's kind of your transformed tan. Okay. Awesome. Moving on. Number 2. Okay, now for cotangent. Cotangent has starting asymptotes at 0 and pi. And let's find out our 5 key points. So this is pi over 2. This would be half of that, so pi over 4. And then this would be like 1 pi over 4, 2 pi over 4. This would be 3 pi over 4. And then 4 pi over 4 would be pi. Now cotangent, if you guys follow the unit circle, cotangent is 0 at pi over 2. It's 1 at pi over 4. And it's negative 1 at 3 pi over 4. So cotangent almost looks just like a flip of tangent, but the asymptotes are different and the key points are different. Okay, so number 2, let's go ahead and graph cotangent of x without any shifts. And when you guys are making your table, let's use our 5 key points for cotangent. It's 0, pi over 4, pi over 2, 3 pi over 2, and pi. Oh, sorry, this is a 4, 3 pi over 4. Those are the 5 key points we're going to use for cotangent. Okay, so let's find their values. At 0, if you guys look at the graph, that's the undefined asymptote. At pi over 4, it's up at 1. Pi over 2 is 0. 3 pi over 4, it's down at -1. And then pi is also an undefined asymptote. Okay, so let's see what's happening. In the x direction, nothing. Okay, so we don't have any changes. In the y, we're multiplying by 2 and subtracting 1. So 2y minus 1. So an asymptote will still be an asymptote. 2 minus 1 is 1. 0 minus 1 is -1. -2 minus 1 is -3. And this is still undefined asymptote. Okay, let's sketch our graph. Okay, so cotangent starts at 0 and goes to pi. And this is pi over 2, this is pi over 4, this is 3 pi over 4. All right, let's see what we got. At 0, it's an undefined asymptote. At pi over 4, it's up at 1. At pi over 2, we're now at -1. At 3 pi over 4, we're at -3. And at pi, we have our undefined asymptote. So connect the dots. And that is your cotangent graph. All right, awesome. Let's flip it over and do a secant and a cosecant. So I'm going to skip 3 and 4 because it's this. If you use this pattern, it's the same thing every time. Okay, but these are different. So it turns out that, well, you guys know cosecant is the reciprocal of sine. So why don't we start by pretending it's just a sine graph? And let's get our key points down. Now, if you guys remember for a normal sine graph, the key points go 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's one cycle of sine. And if you find the sine values at these 5 key points, sine of 0 is 0, then 1, then 0, then -1, then back to 0. That's just straight off the unit circle. Okay, but now let's find the reciprocal of sine. Now let's find cosecant before any shifts. Okay, so in this box here, we're going to actually do cosecant. And all cosecant is, it's the reciprocal of sine. So we're just going to take the reciprocal of all of our sine values. The reciprocal of 0 is an undefined asymptote. The reciprocal of 1 is 1. The reciprocal of 0 is again an undefined asymptote. The reciprocal of -1 is -1, and 0 is another undefined asymptote. Okay, now from cosecant, let's get all of our shifts that this tells us. So no changes in the x, but in the y, we're multiplying by 2 and adding 1. So 2 times the cosecant plus 1. Now make sure you're going off this cosecant, not the old sign. Okay, so undefined is still undefined. 2 times 1 plus 1 is 3. Undefined is still undefined. 2 times -1 plus 1 is 0. And then undefined is still undefined. All right, so let's see what this guy, oh my gosh, did I write that big? Okay, let's see what the graph looks like. So we're going from 0 to 2 pi. I'm just getting all my key points labeled here. Okay, let's see what we got. At 0, we're at an asymptote, undefined. At pi over 2, we're at 3. At pi, we have another undefined asymptote. At 3 pi over 2, we're at 0. And at 2 pi, we are at an undefined asymptote again. Okay, so here's what happens. Secretly, we have a sine curve here. Okay, it just got shifted, right? Do you guys see the sine curve? It just got shifted, and the zeros became the asymptotes. And then here's the trick. If it looks like a hill, for cosecant, it becomes a valley. And if it looks like a dip valley, it becomes a hill. You're just flipping the max and the min. So this is the graph of cosecant. So it got multiplied by 2 and it got shifted up 1. Okay, now let's do a secant, and secant is the reciprocal of cosine. Okay, so let me get my colors here. So I would start by graphing cosine. Just normal cosine, no shifts or anything. Let's just get our 5 key points down. And cosine, just like sine, the key points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, but let's follow cosine around the unit circle. At 0, it's 1, then 0, then -1, then 0, then 1 again. That's your cosine values. But we don't want cosine, we want secant. So why don't we take the reciprocals of all of the cosine values to get the secant values? So reciprocal of 1 is 1, reciprocal of 0 is undefined asymptote, reciprocal is -1, reciprocal of 0 is undefined asymptote, reciprocal is 1. Okay, now let's do any shifts. Okay, well, it says 2 times x. So for the shift in the x, it's going to be x divided by 2. Remember, the horizontal is always opposite. And then in the y direction, we're just making all the values negative. So it's just going to be negative of whatever this was. Okay, so let's take all of our x's and divide by 2. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. And then all the secants we're just going to make negative. So -1, still undefined, +1, still undefined, and -1. Okay, let's do it. So when we make our graph, let's see what this looks like. Okay, so the x's, we have 0, pi over 4, pi over 2, 3 pi over 4, and pi. And then let's see, at 0, we're at -1. Pi over 4 is the asymptote. Pi over 2, we're at 1. 3 pi over 4 is another asymptote. And pi is -1. Now again, I hope you guys can see the negative cosine curve there. But since we're doing the reciprocal, the zeros became asymptotes. Any hills, remember, become valleys. And then for cosine, you're going to have 2 half valleys, and they become half hills. So they just get flipped down. So this is one period of cosine. If you would prefer, you can just extend this over and find the new asymptote, this would be negative pi over 4. If you'd rather have it look like that instead of 1 full and 2 halves, that's totally fine. Okay, a lot of stuff going on here. We will get to practice this the whole next day. Thanks for watching.